All right, so in this video, I'm going to cover actually a few different topics. A little bit of it is just going over what our toolbox looks like right now and how to use all the different reasonings that are listed there. Some of them I snuck into properties of triangles as reasons, so I just wanted to put them into your toolbox as things that you could use in the future and kind of go over how we could use those. So we've talked about this a couple times, but we know that the relationship between all parallel lines, as long as they are on a coordinate plane, they have the same slope. So if we have two parallel lines, we know that they have the same slope, and if we have two lines with the same slope, we know that they are parallel. That's what the if and only if part of this theorem really says, that we can go back and forth between the slope and concluding that they are parallel lines. And the same thing is true for perpendicular lines. That relationship is not as clear. They are perpendicular if the product of their slopes is -1. So if I take the slope of line A times it by the slope of line B, I should get -1. So if I can show that in a proof, that is confirming that these two lines would be perpendicular. So another thing I snuck into the properties of triangles proofs was the application of different formulas. So let's say I was trying to show that these slopes actually did multiply to give me -1. I would have to actually apply the slope formula to show the slope, to find the slope. So the reasoning for that would just be the application of a formula that we know to work to find the slope or the distance or the midpoint, and we'll gain more as we go. So here you can see in our toolbox we have our new collection of triangle congruence theorems, as well as some old ones that we kind of talked about, but I just wanted to clarify some things about them. First off, just the definition of an isosceles triangle and an equilateral triangle. They are defined by their sides, not their angles. So even though an isosceles triangle does have congruent base angles, that actually isn't by the definition of a isosceles triangle. You use the base angles theorem to either get to that or get from there to the congruent sides, which is how we define our isosceles triangle. A angle bisector, a segment bisector, and the reflexive property, the top three on this page, I'm going to go over in a little bit more detail here. So I just wanted to clarify what the reflexive property is really used for. It seems so self-evident that it doesn't seem like we would need to say it, but we're talking about things that are congruent to themselves, an object, an angle, a line, a figure. The whole shape might be congruent to itself. And the reason we might need to say that is because sometimes parts of shapes or objects in shapes are used twice. So they might be used in two different triangles, like this side is a part of this triangle on the left side, and it's a part of this triangle on the right side, and we would say that it's congruent to itself, so that I can say that parts of this triangle are congruent to parts of that triangle. That's really where the reflexive property comes in. When I'm trying to say that I have, let's say I was trying to say all three of these sides are congruent to all three of these sides, I need to actually state that this is a part of that and a part of that, and since it's a congruent part of both triangles, then I actually have all three sides congruent. So it's a way to use a part in two different shapes because it's the exact same part. A bisector, just in general, is talking about splitting something into two equal parts, which means that they're congruent. So this side, let's say I actually labeled this by its points A, B, and C. If I know that this is a bisector, a segment bisector, I could say that AB is congruent to BC. Just by the definition of a segment bisector, we know that that's going to be split into two equal parts. Same thing with an angle. Let's say I label this angle as, let's call it X and Y. If I know that this is an angle bisector, I can say that angle X is congruent to angle Y, just by the definition of an angle bisector.